Welcome back to Pre-Algebra Chapter 5, Section 1 in this book. And what we're going to talk about is called rational numbers. I felt very official pointing with that. Okay, so what is a rational number? One of the best ways to understand what a rational number is to find out what the opposite is. And if we were sitting in class, I'd say, what do you think the opposite is? And kids would say, not rational. And I said, very close, irrational. So what is an irrational number? We're going to learn that first. An irrational number are numbers like pi, the square root of 2, the square root of 3, and these are numbers that have decimals that go on forever without getting in a pattern of repeating. So pi is like 3.14159, and it just goes on forever without getting in a pattern of repeating. So what rational numbers are, they can be written as a fraction. Also, they will either have a terminating decimal, meaning that if you convert that fraction to a decimal, it will end up being something like 0.25. That's it, no more. Or it'll go into repeating. Like if you did 1/3. 1/3 is a rational number, and if you put it into your calculator, 1 divided by 3, you get 0.3333333 forever. So it's a repeating, it repeats. 0.3, and how we show that is with a bar on top. Now if you do 2/3 on your calculator, it does 0.666667. That 7 isn't really there, it's just your calculator rounding the last 6 up. So it's really just 6 forever, all right? So then there's another thing called whole numbers, which is in a Venn diagram in your book, which makes me think of Perry the Platypus and Dr. Diefenschmerz, whom I love. But anyway, whole numbers are 0, 1, 2. They're positive things, no decimals, whole numbers. Integers also include the negative numbers. So integers are like whole numbers plus the negative ones. And now, I have always said integers. My sister says integers, and I thought she was dumb mispronouncing it, but I looked it up and it's an alternate pronunciation. When I went to college, my main professor, Dr. Thomas, I was a chemistry major, was British. So I say a lot of chemistry words that I learned the first time from him the British way, like wrong, for here in Georgia. But like I knew laboratory we say laboratory, I knew aluminium was aluminum, but there were a lot of them I just learned his way of saying it because he said this is that, and so that's how I said it. So can't look down my sister about the integers anymore, but I like integers. All right, so a classic pre-algebra problem is to convert this to a decimal. Now back in middle school you probably did it this way using long division. This means 3 divided by 8. So you put 3 under the radical, 8's on the outside, and then you use this little pattern. Dracula's mother sucks blood daily. Is that the one you learned to do it? It's divide, multiply, subtract, bring down, divide. There is a pretty cute little video, probably on YouTube somewhere, of some middle school kids learning this, and there you go. Divide, multiply, subtract, bring it on down and bring it on back. Divide, which is pretty cute, but I think Dracula's mother sucks blood daily is even better. All right, so you start off with Dracula. So you say, does 8 go into 3? No. Does 8 go into 30? Yes. So you bring your decimal up. How many times does 8 go into 30? It goes 3 times. So now we multiply. Dracula's mother, 3 times 8 is 24. Then we subtract. 30 minus 24 is 6. Then we bring it on down and bring it on back. And bring down the 0, because Dracula's mother sucks blood. And now we divide again. And we say, how many times does 8 go into 60? It goes 7 times. 7 times 8 is 56. I always think of this as the cheer. 5, 6, 7, 8. Who do we appreciate? Me. Yay, me. All right. It's more fun if you cheer. All right, does that surprise you? I was a cheerleader back in the day? Probably not. All right, because I like the cheers and the claps and all that. All right, so next we're back to that we subtracted. So now we bring down another 0. And now we divide again. How many times does 8 go into 40? It goes 5 times with 0 left over. So this converted to a decimal is 0.375. Now, that was 1985, back in the dark ages, the 80s of my childhood. So this is 2020. Maybe you're even watching this a different year. But we use our calculator now. So I want you to remember how to do division, because we'll use it later in dividing polynomials in Algebra 1 and 2. But right now, we're going to use our calculators for these, because that's how I want you to get in the habit. So on your calculator, do 3 divided by 8, enter, and you should get 0.375. 5 divided by 11, enter. 0.45 repeating. You make the bar, it goes 4, 5, 4, 5, 4, 5. You put the bar over both the 4 and the 5. What about if it's like this? First, you just write the whole number in the decimal, then do 9 divided by 20 on your calculator, and it's 4, 5. What about this one? Here they want us to go back the other way, to go from a decimal back to a fraction. This is how you do it. You look at the decimal and you see how many places are here. There's just one. There's one place. Remember place values, 1, tens, hundreds, all that. And then you go back the other way, tenths, hundredths, thousandths. Those are hard to say. So there's just one place here. So I put a 1 with 1 0. Because there's one place, I put 1 0. And then I write this number on top. So 0.7 is 7 tenths. If it has a whole number, you just write the whole number big. And then we do this one. This is going to be our fraction. How many places does it have? 2. So we write a 1 with 2 zeros, then we write the number on top. Alright? So practice those, they're not all that hard. This is a classic pre-algebra problem. We have to put these in order from least to greatest. What you're going to do is use your calculator. Negative 5 divided by 4 is 125. 0.20 is already there, but because this has 2 places, I want all of these to have 2 places. They'll be easier to compare, so I augment or add 0. That one's fine, I just bring it down. That one's fine, I just bring it down. 5 divided by 2 on my calculator is 2.50, and negative 13 divided by 3 on my calculator is negative 4.33. So we're supposed to go from least to greatest. So which of these is the smallest? It's going to be the most negative on the number line. So the biggest negative we have is that one, 4.33. So that's our smallest, that's our least, but we don't write this, we write it in its original format. And when I do this, I mark them off, because organization is everything to me in math. Okay, the next one, we have a negative 3, so I think that's next. And its original form was negative 3. Here we have a negative 125, so I'm going to do that one next. Negative 5/4, mark them out. Then negative 0.2, I'll get rid of my augmented 0, I don't need that anymore. Then 2.5, which is 5 halves, mark that one out. Then 4.31. Ta-da! We did it. Alright, that's not bad. That's a very classic pre-algebra problem. Alright, see you later. Math is great.